chers collègues, chers étudiants, chers invités, c'est un grand plaisir de vous souhaiter la bienvenue à NCS dans le cadre de cette conférence qui est présentée dans le cadre d'un partenariat que nous avons avec la société chinoise CEIEC et sa filiale donc Crescent. Ce sont des sociétés qui sont très actives dans le domaine des technologies, notamment des technologies émergentes telles que les big data, l'intelligence artificielle, l'Internet des objets et ces différentes applications. La conférence va être en anglais, donc si vous permettez, I'll switch into English. So it's a real pleasure to welcome the CEO of Crescent here, who will be delivering a talk about artificial intelligence, the emerging trends and different applications of artificial intelligence. And I seize this opportunity to thank CEIEC and Crescent for the very strong partnership we're trying to develop with them here in NCS and in Mohammed V University in framework of the innovation ecosystem we're trying to set in this school. Have different companies, startups already in NCS Valley, and we're trying also to develop some collaborations with the CEIEC and Crescent in framework of the call for proposals our ministry and the Ministry of Industry has recently launched about artificial intelligence and its applications, and I'm looking forward to develop different initiatives in this regards with both of you, and I'm very confident that the talk will be very interesting. Unfortunately, I will not be able to stay with you. I have another commitment right now and I should leave. So once again, thank you so much for your time and your contribution to the development of this initiative.
Hi everyone, my name is Ivory Liu, or if it's easier for you, you can just call by my English name, which is Ivory, so you can just call me Ivory in case you want to ask questions. Before I start, I want to show you a video, which is what we do in China in using big data and AI technologies. What is the smart city look like?
City is the guardian of humans' existence and development, the guardian of civilization's inheritance and evolution. City is now getting intelligent, making life in order, convenience and happiness, with safety as the foundation. This is what we are working on. We perform analysis, collision and mining to massive data, only to find out the most valuable information. Overseeing security data, industry data, and correlated intelligence, we don't miss a corner. From total surveillance to precise tracking, we link up the past, present, and the future. For a long time, we are devoted to improving the efficiency of emergency management. We have worked out integrated intelligence and warning platform, which gathers public security data from all the cities to obtain accurate risk prediction. By high-speed big data computing, we calculate all possibilities, leaving no risks undiscovered. To keep the city safe, no one could be left out. CEIEC's Eco-Evolutionary Emergency Management Platform is designed based on sharing resources, security services among emergency responders of police, fire, traffic, and medical departments. We truly believe that sharing brings highly efficient collaboration. Police and citizens both build the city. Maximum community involvement extends security into every corner of daily life. CEIEC's cloud-based public security service platform provides two-way communication between government and the public, allowing citizens to play an active role in public security construction. CEIEC's Intelligent Transportation System offers not only multi-aspect monitoring, but also in-depth big data mining and analysis. For every traveler, we provide comprehensive traffic information to make everything intelligent and efficient. Wherever you go, we are your guidance. Extracting experience and wisdom from our increasing intelligent city projects in Venezuela, Ecuador, Trinidad and Tobago, and in Angola. We keep fulfilling our corporate mission to make persistent efforts for people's safety and happiness. We are CEIEC, with consistent dedication and for every piece of happiness.
Hello. Before I start, I want to understand a little bit about you. My initial understanding really is that you are all studying in either engineering or big data or AI. So my question is, how many of you think you, after you graduate, you will work in company and in related to all those new generation of information technology? So if are you working in this technology area? So how many of you are gonna work for companies like in the future for different industries as you expect now? Oh, not many. So all others are gonna stay in academics? Okay. Probably half of you. I ask this question because my presentation today is gonna focus on how technologies are used in China in different industries. It's not really about technology itself. So what is algorithm and what is deep learning? This is not really about technology. It's about the application of technologies in different industries. So hope this is what you want to hear. I start a little bit with the percent group. Just now from the video, you see a name, that's a CEIEC. That's the parent company of Percent. Percent is a company that is only 10 years old, focused on big data and AI technologies. We are based in Beijing, but we do have branch offices across China, and right now we serve clients across the world. Oh, by the way, we do have a lot of collaborations with Chinese universities as well in different cities. This is evaluation from the American research company that is named Forrester. Maybe you have heard of it. Forrester last December evaluated Percent as a strong performer in terms of predictive analysis and machine learning solution. So you can see there is one leader at the far right corner. That's SAS, which is an American company. And in the second tier, that's a strong performer. Those are three companies. One is Percent, another one is SAP. I assume that SAP is very familiar to all of you. And then Alibaba. Have you heard of Alibaba? That's Chinese. People all say Alibaba is an e-commerce company. It's not. It's really not. It's a big data company. All of its business are driven by data. So we are in the same layer, same category as SAP and Alibaba. As a very young company, we are quite proud of it. Here is what we do in a very simple way. So we can look at this graph from the bottom one. From the bottom, that's a big data operating system. We call it BDOS. This is one of the first products that we launched in 2015, so that's 4 years ago. This basically does data asset management. And in the middle level, actually in the middle level, that's data mining and data analysis. There's a lot of technologies, but here we put two very most important technologies. One is the knowledge graph, another one is an NLP, natural language processing. The middle level is correspondent to humans' cognition, yeah. But this is for machine. And at the top level, those are applications for different industries. So these three layers correspond to what we understand how data creates value for different industries. Data comes in as a raw material. That's why data is called new oil in the information age, new information era. And then it gets processed in the middle so that a machine can understand, quote unquote, understand all those information. And then the output is built into the business processes of all different industries, so that people who do not understand code at all, who do not understand technologies, they can do their business through all those applications. So that's kind of like the three layer: data, raw material, and processing, and then output incorporated into business processes. A very brief introduction of what we do present. We focus on 4 areas. You can see at the top, we serve businesses, we serve government, and we also provide SaaS, that's a software as a service, to small and medium-sized enterprises. Those are 3 core areas of our business. At the bottom, supporting everything, that's the data. We do have about, let me see, 500 million users data in China, which means we follow internet users, their behavior on internet, on different websites. E-commerce website, or reading, or BBS, music, and we capture all their behaviors from online. So that's the database we have about Chinese internet users. So that's a very brief introduction to Percent Group, what we do. And here, let's talk a little about how we understand what is data technology era. So on the left side, you can see this is an IT era. That's much earlier, in the last about 20 or 30 years. It has been the IT era. So what does IT era do? Fundamentally, it just transfer or digitalize everything. Just now I talked about consumer behaviors or online behaviors. That's the digitalization of human behavior, because we do more and more activities, work, life, leisure on the internet. So internet captures all of our behaviors and then transform those behaviors into massive database. So that's about human. Aside from human, business processes, business operations are digitalized as well. And more and more machines and sensors are digitalized as well. So that's what IT does. IT digitalizes human behavior, business operations, and increasingly many, many more things. But what DT does, on the right side, DT turns data back to businesses. Data is just a raw material, and based on data, we can not only build more efficient business model or run organizations in a more efficient way, but also data can create totally new products, services that can change people's life in many different ways. So this is what we call digital twin. You might have heard of this term. This is a really old term. It's not a new term. But digital twin only become reality after the whole process of digitalization. And the process of digitalization is still going on. It's not over yet. Then you will find we have two worlds. One is the physical world. That's where we are, you and I, the whole room, all of the chairs, people. And then there's a digital world. Everything can be digitalized. And then when the physical world is transformed digitally enough, the digital world can do its own thing, independent of the physical world. That's why we have this brain that's half in the physical world and half is totally digitalized as well. So that's what digital twins mean. We have two versions of reality. Back to business. Here are some core industries, because all industries are digitalized at a different pace. Some are transformed earlier than others. Those are some key industries, such as the finance. Finance industry, like banking, insurance, security, those are among the first waves of industry to be digitalized. And then manufacturing, eventually, more and more with the automatic manufacturing. And then retail, automobile, etc. Those are, and now, currently, a lot of government are being digitalized. This is my first time to Morocco, so I do not know the process in Morocco, but in China, smart government, digitalized government, that's a very hot trend right now. So the government, no matter it's at the national level or provincial level or city level, are all being converted into digitalized government. Yeah. So those are some key industries. What is supporting all those digitalization? On the one side, this is the AI technology driven by big data. On the other hand, this is the business intelligence. Business intelligence basically is industrialized because every industry is different. So even if the driven technologies are similar, but in different industries, you see very different versions. So that's a business intelligence. AI combined with the business intelligence become digitalized new industries. That's the logic. So at the bottom, all those technologies are quite common. They are general technologies, so they can support all different industries. And data, that's at the very, very bottom. That's the new production materials. So what is really AI? We talk about business intelligence, that's about industry know-how. And what is AI? AI is really an old concept as well. And this is the definition of Turing test. So if you talk to someone you cannot see, whether you can tell that's a machine or it's a person. So if the machine passed the test, that's artificial intelligence. So you can't tell anymore whether it's a human being or it's a machine. And those are key technologies. Those are technologies in Word, in red, the first four. Those are more related to cognition. And those are in blue. Those are more related to interactions, like human-robot interaction, the human-machine interactions. Those are all quite a simple concept. And for AI, they have 4 different directions to develop. If we, those are, it's a matrix, right? And on this level, this is either human or rational. Okay, so there is a funny joke here. So by this categorization, we assume humans are not rational. Okay? Either you are like human, or you think or act rationally. That basically humans are not quite rational. And then on the horizontal level, you either have a think, then it's a black box. So you think, I see the result, but I don't know how you think. Even if you yourself don't know how you think, how you process information. So whether it's a think, which is hard to observe, or you act, which is easy, which is salient to observe. So we got 4 different areas. And this is a typical area that is easy to understand. So if a machine acts rationally, what's the result? One example is a driverless car, automatic driving. You don't know how machine make all those decisions, whether to turn right or turn left, but a car can drive in the street totally rationally. Yeah. So that's an action, and that's a rational action. So here, for AI, the future direction, this is the direction for one type of AI technology, that is to act rationally. If you think about think rationally, okay, we just said we can observe how people think or machine think, but what would be an example for machine to think rationally? That's basically, for instance, reasoning. Reasoning, if we say, what's an example? Have you ever, if you use e-commerce site, have you ever seen that a window, it says, I guess you like it, or I recommend you buy this? That's the result of a calculation by machine based on your preferences and the features or attributes of different products. So the recommendation is a result of think rationally for machine. So that's one example. That's another direction that AI would go, what AI will do for us. If we think about act like a human, let me think an example, maybe. What? Sophia Robot, yeah. Or WeChat, or chatbot. Yeah, all those chatbot. You can talk to a chatbot, and then that's the speech is an action, and the chatbot can get angry. I have seen like children playing with Siri and ask Siri about really stupid questions like, do you like me? Do you like me? Are you female or male? Like, and then Siri will get really upset. So they act like a human. But this area is really the only area that so far we really can't find any example because we are not there yet. Like think like a human. Think like a human. Meaning AI not only can do reasoning, but also can have feelings, can have emotions. So that is the only blank area so far for AI's applications. So those are like 3 typical schools of AI that scientists or engineers when they develop AI methodologies. So symbolism or connectionism or behaviorism. Those are different, three different schools. They became major methodology at different times. But eventually, those are kind of like the development of different schools. But eventually, people realize every single one methodology is not enough to develop AI fully. So at the end, it becomes a combination of different methodologies. Like for instance, this one, logic learning machine. This is widely used currently, like in many different areas. This one is based on symbolism, but this one uses deep learning technologies as well. If we look at this one, knowledge graph and embedding, this one is based on symbolism as well, but plus connectionism methodologies. So eventually, it's a combination of different schools that make AI more and more intelligent and more and more able to do different things. It's not just any one of those single methodology. This is a landscape of key big data and especially AI technologies that are used in different industry applications today. Again, in China. Yeah, I'm not very sure about what is happening in Morocco. Maybe later on you guys can tell me what is the stage in Morocco. So at the bottom is really all different types of machine learning technologies. And then here, in the middle part, we have 3 different layers for AI, really like how intelligent AI is. This is artificial intelligence. To begin with is perception. So perception is correspondent to humans' 5 senses. It's like what you see, you hear, and how you speak, how you interact with other people. So that's perception. That's the perception level. And then it's cognition level. Cognition level, if we remember, when we are at the first page, at the Turing's test, especially those 4 technologies in the color of red, like natural language processing, knowledge graph, those are all in the category, in the stage of cognition. Those are all, each one of them is one quite specific technology. And then it's decision. Decision basically means problem solving. So we got all those knowledge, information or data, and then we process those information and turn them into knowledge for the only purpose of solve a problem. So at the end, the highest level of artificial intelligence really is about making decisions or help people, help organizations to make decisions. And then all those technologies combined, they can support either to business or they can support to customers, to consumers applications. So that's kind of the technology roadmap, or it's an outline of all those technologies. What do we do? This is we, meaning percent group. We focus mostly on all those red boxes. For the blue boxes, those are more common technologies that you can find open sourced products. So we mostly integrate those technologies in blue boxes into our products or into our services. This is what we what do we do mostly the 4 industries we do the most in China. Finance, manufacturing, media, and publication, and public services. This is what we do the most. Not that we don't do other industries, but those 4 industries are most advanced so far in using big data and AI technologies. Those are quite specific technologies we use, and those are more fundamental technologies we use. So those are more industry general. But these applications are quite specific to different industries. Here I want to say something about the breakthrough or key innovation we have achieved in serving those industries. The number 1 is really the combination of big data and AI. Oftentimes we get the question as well, so what's the difference between big data and AI? What's the difference? So without data, AI cannot operate. So any AI application needs loads of input of data. But to process data, especially multi-source, heterogeneous, massive amount of data, there is a whole set of specific technologies. If you look at this part, these are the collection of some key technologies in big data, and this is how we use technologies, AI technologies, to transfer all this data into knowledges that a machine can use. This combination is integrated platform of data and the business processes as well, so that data can come in at the bottom, and then at the end as output. Normal business people can operate all those systems. That's the process to combine big data and AI technologies. One of the key technology we use is a dynamic knowledge graph. Knowledge graph, there really is no general knowledge graph. All knowledge graph is industry specific. So this is a very simple demonstration of what is a knowledge graph. At the bottom, at the top, those are facts of the physical world. What are the facts of the physical world? Like, for instance, you and me, and this person, that person, your name, that's the facts of life. And then there are many facts about one person, your age, your gender, your education background. Those are facts about one person. And then there are also facts about physical objects, like a building. So the building is a cinema, or the building is a residential house. Those are all facts in the physical world. That's this part. And then if you just give machine all those facts, machine wouldn't understand. So we need the bottom part. We call it based on ontology. Ontology gives label to each category of objects. For instance, people. For instance, building. For instance, book. For instance, phone, telephone. So under each label, you can have a long list of specific individuals. So that's the bottom. And put them together, and we still have to build a relationship between all those objects. For instance, this sir, like he is my colleague, so our relationship is a colleague. Your relationship might be classmates, and my relationship with my house, maybe I'm the owner of my apartment. So there are relationships between different entities. So with the different entities and the relationship between all those entities, we have knowledge graph. So you might wonder what we can do with all those knowledge graph. One very popular usage of knowledge graph is in security area. Security meaning, for instance, a city wants to control the entrance of criminals or potential criminals. So how can a knowledge graph help the city to keep the city safe? So what do we usually do? We usually, from the police station, they will have a list of ex-criminals, for instance. And then they have all those facts about those ex-criminals. All those facts meaning which school they go to, where do they live, and what's their hometown, etc. Those are all labels of those, for instance, like ex-criminals. And then by those labels, and remember just now we said we build connections between entities, right? So we can track who those people make phone calls to, who do they travel with, who do they wire money to through a bank. So those are relationships. And then we can identify a larger, much larger group of people who have a close relationship with those ex-criminals. And those are the people we want to monitor closely. Does that explain? So that's one application of how knowledge graph can be used in the area of security. Yeah. And even if there is a vehicle, a car or truck that is registered under the name of those ex-criminals, the surveillance camera in the city will check all those plates of those cars. So once they see the car, the plate of the car that is registered under the name of the ex-criminal or a close friend of the criminal, they will watch the car, see where the car goes and what it's doing when it enters and when it leaves, especially whether the car is getting close to some very important building, etc. So that's what a knowledge graph can do in real life. It can be used in many other ways, yeah. But that's just one example. So this is one of the key technologies for machine to solve a problem for human being. That's a dynamic knowledge graph. Another technology is NLP. NLP is not new, but one of the main difficulty in terms of technological development in NLP is the accuracy rate. We all know that human language are ambiguous. If I say, you are really good, well, that if I say in this way, it means one thing. If I say in a different way, using exactly the same word, exactly the same sequence, if I say, you are really good, depending on the context, it might mean something very different. It might mean, yeah, you are really, really, really good. Or it can mean, I'm really angry about you. I'm saying something in an ironical way. So that's the ambiguity of a human language, which is very different from a machine to understand. So if a machine hears this, it can say, oh, you are really good. The machine will think it's positive. So that's one big challenge for machine to really understand what it really means. So The way to get through it is not to teach the machine just to understand the sentence word by word. It's not a translation. It's really to give the machine a lot of context. If I say you are really good, if I mean something different from the literal understanding of you are really good, it must have some context. For instance, you have done something that's really annoying, and then I said the word. So providing context to machine so that the machine can really understand what it really means, that's what we call like training, right? Supervise the training of machine learning. This is another key technology that we use. There's another one, is a deep transfer learning. We just say that for machine to learn anything, it needs a lot of materials. But this technology can enable, we can use only 10% of usual sample size, so that the machine can get the same accuracy result. This is another quite important and new technology. Here are some examples, cases of what we do with all those big data plus AI technologies. This is in Chinese, I apologize, but for a long time people argue about one thing, that is, can machine do creative work? So it can do computation, it can do math, it can do storage. Those we all understand, but can machine do creative work? This is the one a small application we created last year, that is to let machine to write poems. And the way the machine write a poem is, for instance, at the New Year, you can, if you want to send a card to anyone, so Happy New Year, for instance, to Mr. Muhammad, and then you can plug this your keywords, what I want to say, your keywords into the input area. Here it is, input area, and then all those red words here, although it's in Chinese, but all those red words are the words you put in, and the machine can incorporate your words into the poem, so that you get a new poem, and then with the words you wanted it in. So that's how the machine can learn to write poems. I'm really sorry that I can't really translate all those Chinese poems into English, but it's pretty fun. At the last year at the Chinese New Year, that we played it, like we sent it around, and a lot of people play. You know, like writing, especially like an Asian poem, is one skill that has been long lost. Very few people can still write an Asian style like poems today. But then we find this skill again, like but through machine. Yeah, maybe it's sad. I'm not sure. This is one case. A different case. This is the real case we did for one bank in China. So this is for micro loan, small loans for people. Yes. The meaning? Deep transfer learning, basically, it works this way. So I give you one example, and then it will be easy. So for instance, if we have a category, say it's cosmetics. So for cosmetics, we have a lot of different products, right? And then each product has a different brand. And each brand has different SKUs. And each SKU has different attributes. So there is a lot of, you can see that's a big tree, right? It's a big tree. So the earlier methodology for machine to learn about this category of cosmetic is to build a whole tree. And then that's a lot of work. Imagine that you have to list all cosmetics and all attributes of each SKU. It's a lot of work. And then once the machine, even if you have done this work, and then the machine knows what is cosmetic. And then next time, if you want to teach the machine about, let me think about another, okay, like shoes or apparels, like women's apparel. And then you get another big tree of apparel. You're gonna tell this is a shirt, this is a skirt, this is a jacket, dress. You're gonna teach a lot of build a big tree again for the machine to understand what is apparel. So that requires a lot of raw materials. So deep learning transfer. Let me go back to deep transfer learning, meaning when we teach the machine about cosmetic, we build a logic tree instead of put everything on the same list. We tell them, first of all, it's like, for instance, cosmetic has like 10 different categories, and each category has a different brands. Each brand has a different subcategories, and each subcategory has a different SKUs. So that's a logic tree instead of really you put on the name of each different brand name there. And that logic tree can be transferred to a different category, for instance, apparel. So when we teach machine to learn apparel, instead of giving the machine skirt or all those different names, we give machine the logic tree first, so that the machine understands there are different branches. And each branch, meaning this branch is the main category, this branch is a brand name, this branch is SKU, this branch is the size, different sizes. So machine learns about the logic of categorization first, and then we put different names on each branch. So this is a different way of teaching and learning. So that's a simple example of deep transfer learning. In this way, we don't have to put all names of apparel into the input pool for machine to learn. The machine can look for different brands in apparel, because through the logic tree, it knows that they should look for the category first, and the different types, and the different brands, and the different sizes. Does that explain? Yeah. So that makes it much easier. So this is back to this case of a loan, like a micro loan. Micro loan, this is a real case. So in this bank wants to give loan to so-called like a white collar workers. So what is the typical feature of a white collar workers is they have stable income. They have this paycheck every month, and the paycheck is more or less the same. So a white collar worker is not an entrepreneurship. An entrepreneur or for startup owner, it might have income this month very high, or for the next 3 months it doesn't earn anything or even lose money. So those are like typical features for a white collar worker. So for any white collar worker or employees, they might have the need to, for instance, buy a house or buy a car. So the bank needs to decide to evaluate the capability of the person to pay back loan, and how much loan it can pay back, so that they can avoid risk, right? Bad debt. In the past, they do in a human way, and they build a very simple model, or they look at how much deposit this person has, or how much collaterals, this person, what type of collaterals this person can provide to the bank, so that they decide how much loan they can give. But in the new way, the system we build for this bank, we put into much more information about this person into the equation. Like for instance, this person's education level. So if this person has a doctorate degree, doctor degree has something like value in it. So if it has a doctorate degree versus this person only has a high school degree, and what's the social circle of this person? So usually this person hang out with high income people or low income people. Those information are from the social media websites or from other resources. And also we put in, sometimes we also look at the posts those people put on internet, just to determine what's the lifestyle of this person. Whether this person has a luxury lifestyle or they have a very simple lifestyle. So of course, put all those information, those are much more abundant than the usual data the bank used to have. Then we can build quite complicated model and to determine whether this person in the future, his or her income will go up or will go down. And also to evaluate if this person cannot pay back, whether somebody in his social circle, his friends or his parents, have the capability to pay back the loan on behalf of this person. So there's a lot of more evaluation the bank can do to decide whether to give a loan to the person and how much loan to give, and what's the interest rate we should put for each person. So on the right side, those are some key data that the system we provided can do for the bank. Like for instance, the marketing effect, that is the scale of the loan increase. So the bank can give more loan, but at a much lower risk. And we can predict far better than before whether this person will apply for a different loan or whether this person can really pay back. So this is a different case. Another case is also about banking too, but this is from a different perspective. So for all those financial institutions, they have financial products. Before people only get interest through saving, put money into the bank, but now there are so many security products or insurance products, and depending on how much risk you want to run, and you can get very different returns. So those are different financial tools and financial products. And again, we can match the attributes or preferences of different consumers, and then evaluate attributes of different financial products, and then do the matching and give the recommendation to different people, recommend different products to different people. So those are some numbers. So from the first time recommendation to fourth time, you can see the more we recommend, we recommend more products to consumers, and they accept it more and more, and then they buy more products as well. This is not just a marketing. This is not just to sell more financial products to people. It's really a win-win situation, because savings, the interest rate for saving is very low. But many people, they can use their money, their disposable income, in a much more efficient and a profitable way. So this is better for the bank, so that they can have more liquidity. And this is better for consumers as well, because they get a higher interest return through all those financial products. Last example, this is the structure, is a system we do for government. Maybe it's too small, but the fundamental structure is the same. It's at the bottom, it's really the data layer. Government actually is one of the biggest data owners. Any government, it has a lot of data. Like, for instance, everyone, when you are born, you have to register somewhere, you know, to get your birth card, and then to get your ID card. So the government has the birth information and your parents' information of everyone in the country. So that by itself is a lot of data about the person. And then through education, through all the schools, the government have all educational history of every person. Yeah, if you go to the public school or private school too. And then you think about medical records, you think about vehicles you buy. For every vehicle you have to register as well. And then other information such as housing. So the government really is the biggest data owner. Yeah, it has all information about people, and it has all information about the city as well, and the electricity and the traffic. So with all this data, but those data are static. We also have another type of data that's real-time data. Real-time data happens every second. Think about data from telecommunication companies, that people are making phone call every second. People are surfing on internet. Those are all information that's real-time information that government can collect. And all those travel data, flights, trains. So this data layer implies data from all different resources. Some are static, some are real-time. And for all those real-time data, if you don't capture and store those data, it's gone. Once it's gone forever. It never stays. So data layer has all different sources, different types of data. Those are, if the government wants to collect and wants to store, it can have a massive amount of data accumulated. And then data support. Once you capture all those data, you gotta have somewhere to store it, right? To have it processed so that it can be used for different applications. So that's the data support layer. Here, service support layer. So if you can't use the data, it's just cost. And it's quite costly to capture and store all this data. So service support layer process data according to different future usage. Those are the service layers. So the government might use data to do a lot of different things, like urban planning, or transportation control, education policies, or population policies. So government can do a lot of things with all this data. And then at the service support layer, depending on what the government want to do, you have to process all this data in different ways. So that's the service support layer, or what it does. So this is kind of very complicated structure of what we do for government, so that the government can digitalize its services based on data. So this is the last page of my presentation. Yeah, I wonder, yeah. Yep. Oh, of course there's noise. Yeah, tons of noises. How noise interact with all of the predictions. Yeah, so from here, data layer to data support layer, there's a lot of heavy labor-intensive work just to get rid of the noise. Yeah. Well, then eventually, that's why just now I said, depending on what you really want to do, you want to come back to choose what kind of data. You don't want to deal with all data. Yeah, that's too much, and then too much noises as well. So through experiences, that's where experience come, have a real good value. Through experiences, you know what type of data here, especially real-time data, that you want to use. Like for instance, if you think about this, like your cell phone. Your cell phone is sending back data any minute. And a lot of all those information are not important. Like for instance, I might not care, how many computer game, you play on your cell phone. I don't care about that at all. So whenever I identify this is a computer game, I just skip it. And then, you know what, like in terms of a mobile phone data, so far, the most important information or most valuable information is location. Yeah, for different purposes. Yeah, some companies, because if they want to do like a real-time merchandising, location is the key. I want to know at what time and where you are. That decides what kind of products I want to push, so that I guess you want to buy. So location is the #1 important information about cell phone. But location is just one of many data your cell phone creates every minute. Yeah. So yes, there are tons of noises. You gotta know how to find the gold, how to find the gold in the sand. Yeah. So that's, I hope through this presentation, I kind of make myself clear that what we do and how we do in different industries. So I don't know what are the questions of your interest.
Okay, so thank you for this interesting presentation. So my question is more an ethical question, okay? You told in the beginning about security in the city, but what about private life of citizens? How we can combine laws of privacy, artificial intelligence, and to make the city more secure and more safe?
Right. My personal opinion doesn't represent my company. It's really a trade-off. It's a trade-off between personal privacy and the convenience or security. So the more convenience and the security you want, you meaning every citizen, the more privacy you will just have to give up. So the only advice is just to be a good person. Don't do bad things.
That, but in others, no.
Totally, yeah. So that really depends on the policy, yeah. And there is an argument, people say, why AI technologies are so far, especially in the application area, why China is so much more advanced than in Europe or in the US. It's because China is much less regulated in using personal data. Yeah. But you know about Europe, especially Germany. It's highly, highly regulated. So every company or research institutions, there are a lot of things that they just can't do because of the regulation. Yeah. That's right. So it really depends on the government.
Well, thank you, Ivory, for sharing with us your knowledge. It's been very technical, of course, but at least we had a lot of, I would say, information about the scientific, of course, aspects of artificial intelligence, and how you're operating in that field, how Percent is operating in that field. Thank you. I personally have also a question about emotional intelligence, that is, of course, a subset, I guess, yes, of artificial intelligence. And how, in my sense, it can be misleading, more than something that can be profitable to artificial intelligence. We know that we can have a bracelet on somebody's, of course, arm that can, of course, convey all the emotions while looking, I don't know, a show, for example, but wouldn't it be misleading because he can show happiness, not because of his appreciating the show, but because of his kid doing something that's, of course, that's good, or showing a good behavior. So how neurosciences are advancing that can, of course, make emotional intelligence fit best or be more profitable to artificial intelligence. And of course, in different fields, not only in, of course, e-commerce or business, but more into health maybe directions or privacy directions, like showing fear, showing other, of course, situations where government can take, or how would I say, la police, security agents can intervene. For example, just an instance. Thank you.
If I understand correctly, you're asking about how AI technologies really deal with the artificial emotions, whether it's true or not. So even if it can smile, can put on a smile face, is a real smile or it's a posed smile because programmed smile? There are two schools, two different, very different understandings about emotion. To start with, I'm talking about human emotions. So there is one category, one group of people, they think emotions are accumulated responses of a human being to environmental cues. We have an example, like for instance, even if a child who has never seen a snake, and the child, for the first time, the child sees a snake, the child is afraid of snake, but this is the first time he sees it. So this group of people, they think this category, this school believes that there's something encoded in our genes, right? Because for thousands of years, a snake is a threat to human beings. So, that result is a calculated result. It's thousands of tons of repetition in ancient times that tells
tells, quote unquote tells the gym that this type of a creature is dangerous, so you should run away as soon as you see it. So for this group of people, they believe our emotion, we are talking about afraid, right? Like fear. Fear is a result of a repeated experiments, of a repeated calculation. The chance for one person to fight against the snake is very low. So that's the calculation. That's the experiments and the calculation, and then that's the result. And the result has a name, it's a fear. Is a logical clear? So this is one school of people, that's the way they understand what emotion is, human emotions. And happiness is the same. So we all know like sweets make people happy. So in the late afternoon, for instance now, if we have all chocolate cookies here, everybody will smile. Like when you eat, very few people will frown their eyebrows when they eat chocolate cookie. Most people smile naturally. So that's a sweet make people happy. So what's the logic? Like why sweets like a cookie or chocolate make you happy? It's not about the chemistry. It goes into your body. It's a result of repeated experiments and a calculation. Because in ancient times, sweet is in scarcity. There isn't very much enough sugar. So whenever you have something sweet, you should be happy because it can save you. It has a high energy. So this is one way for psychologists to understand what emotion is. It's just a result of repeated experiments and calculation, either for survival. Like everything is for survival. So this is one group. Another different school understands emotions in a different way. So the other group that's more closer to your question. They mean emotions are a reflection of our experiences. So that's a different understanding about emotion, which means there is a precondition for emotions to exist. That's a self-awareness or self-agent, like free agent. You have to be a free agent who has self-awareness to experience emotions. That's a different school to understand emotions. So if you agree with the second type, AI doesn't have emotions so far. No. And whether AI will have emotions in the future really goes back to that hotly debated topic, that is whether AI will have self-awareness, which is not proven so far. But if you believe in the first school, human emotions are a result of repeated experiments, and a result of a calculation. Machine can have emotions. Yeah. Does that help?
It's good enough, thank you.
It really depends on which one you believe in.
Right.
In one way, we are all robots. Like, some people believe that. We are all robots. Like,
fine, thank you.
like, for instance, which color you like the most? You personally, like?
Blue.
Blue. So why?
Different reasons.
If I believe in the first group, whatever reason you tell me, I would say you make up the reason. You really don't know why you like the color of blue. The real reason may be when you were a baby, your mom wrapped a blue blanket around you. So after you grow up, whenever you see the color of blue, you feel safe. That's why you like the color of blue. But you don't remember when you were an infant. So you don't know the real reason. So you make up all different reasons to explain why you like the color of blue, which are all not true.
Well,
because in the nature, a lot of things that we like are blue. The sky is blue. Sea is blue.
That's right.
Things that we like
Well, I can say
are blue. So that's why we like blue.
I can say those are all postdoc explanations.
Yeah, but then it can change. I can move to
Green.
Green, definitely.
Sure.
That's why I just rather think emotions can change, and it cannot be reliable when it comes to intelligence, artificial intelligence.
Yeah, but there is a difference between emotions and the mood, right? Mood changes quickly, but emotion, usually we mean something deeper, something more lasting than mood. So mood can change anytime.
Really personal. It's really intimate. It's really different from one person to another. I mean,
I see you really belong to the secondary school, like the other type. You are the secondary. But you think about the Turing's test. Yeah. How can we decide whether this machine has intelligence? So the test is when you talk to it, whether you can tell it's a person or it's a machine. If you can't tell it's a machine, that's intelligence. So this logic clearly belongs to the first group. Yeah.
So, for example, in your slide here, how did you choose the colors? Okay.
Yeah.
The first one can be green and the other one can be blue, but you decide that it will be like this. There is a reason.
There are reasons, but you never know what's the real reason. That's the problem.
No, for me, we need to combine psychology and technology. If we combine psychology and technology, we can have more interesting results in artificial intelligence.
True. Yeah. AI shouldn't be just about technologies and algorithms per se. Yeah.
that's why I said how neurosciences are advancing and combining, of course, results from artificial intelligence and technology to come out with better results and more reliable results.
That I agree. And people are now trying to put, for instance, like ethics into algorithm. Yeah.
We don't need to concentrate the discussion.
Yes. Okay.
The discussion should not be peer-to-peer.
Yes.
Let the audience see the question.
There's other questions.
First of all, thank you for your interesting presentation.
My honor.
Briefly, for a sensitive field such as medical field, how we can trust artificial intelligence technologies?
Yeah, yesterday we were in Casablanca, and then there's a Professor Rashid Gallowing, from Switzerland, but he's a Moroccan, He's a Moroccan. He gave a speech about artificial intelligence, and one of his main area of his research is really about whether we can trust algorithm. So you asked a very good question. That's for the whole hour, like he was talking about whether we can trust algorithm from machine. Of course, he is very much concerned about all those error that the algorithms might make. Because you remember, like we say, what we do now, like percent, we understand the AI from perception to cognition and to decision making. So I just said the ultimate goal for AI is to facilitate or make decisions for human beings, right? So your question is, how can I trust decisions made by machine? From our experiences, I can only say experience from our applications in different industries. Human make errors too, we have one project that we work with the government agency to make a decision whether the agency should recall automobiles in the market. And we found that the machine, after we build the system, before the system, they have to collect like for instance, like 20 or something experts to work on the case for almost 3 months. Piles of complaints or information about the performance of the car. They have to work on 2 to 3 months, about 20 experts, and then make a decision. After we make the system, the machine learning system, to make the decision, any like junior level person can work with the system for only 2 hours and to make the decision. Clearly it's much more efficient, right? It's much more efficient, much less costly. And from our, you say like car recalling is a quite important decision as well. Because if the car has a flaw, it might lose control, it might kill people, or you might have a car accident. So that decision is quite critical as well. So from our experience with this decision system, we found it's not only more efficient, but it's no less accurate or even more accurate than the experts group. So, but we haven't done anything in medical fields yet, but this is in a different field, or the car recalling, right? But that's what we found. So I think in theory, that's the practice, that's a real case. But in theory, I would say human doctors make mistakes as well. And in theory, machine actually make less mistakes than human doctors. Yeah. But for whatever reason, this area is going very slow. Yeah. In theory, everyone believes that AI can have a huge implication in medical services, but in fact, it goes very slow. And you remember like the Watson, IBM's product, AI product, cognitive science, cognitive product, Watson. Watson uses medical treatment, like cancer, as its one of the first application. But then the whole service was just canceled last year. Huh? So maybe there is something that cannot be replaced easily by machine about human doctor. But we are not in this area, so I think I can't say with authority, but I only can talk about this in theory, in a theoretical way. Yeah. Can solve a problem for everybody, for any people. You mean can or cannot? In any time. In real time. Oh, we already have this product. I just didn't bring the product with me. I was telling my colleague, because after I came to Morocco, because I don't speak French, so I got into quite a lot of troubles. And then I was telling them very soon, like in 1 or 2 years' time, even today, like language will not be a problem anymore. And then my colleague was laughing. He said, our translator, he said, she will lose job like very soon. But instantaneous translation, no matter it's in text message or it's in voice, it's already there, yeah. I think so now it's not very popular, maybe because people haven't just turned it into a real product yet. But the technology is already very mature. Yeah. Next time when I come to Morocco, I'll make sure that I'll bring a software that we produced by ourselves. And then using that software, even if I have to carry that computer everywhere I go, but then I will not need a translator anymore. Yeah. It's already there. Yeah.
他说下次他就说你做介绍的同时也不是说需要你同时翻译，就在你的这个 PPT 下面把你说的语音自动转化成这个法语系统。
Oh, that's not a problem anymore. No, the technology is already there. Yeah, yeah, and it's quite mature. Yeah. But we have a product that's a deep translator. we call it deep translator that targets small languages. You know that French is a big language. A lot of people speak French, but there are many minority languages that only very few people speak. So our product focus on those small languages. So even for small languages, the technology is already there. Yeah. But you know, like for simultaneous machine translation, the problem is not about technology at all. It's really about the data again. It's about, like for instance, if we only talk about weather or talk about food, it's very easy to translate because there's only so much category. It's very easy for the machine to learn about both those category of vocabulary in both languages. The real problem is about any very specific area, like for instance military, for instance nuclear. And maybe movie star. Like movie star in Morocco don't exist in Chinese. So the machine has nothing to learn about because there's no Chinese materials about Moroccan movie stars. So that's the problem for machine, for translation. It's not really about technology. It's about whether you have all those vocabularies, all those words in both languages. So long as you have both. It's very easy for the machine to learn both languages and do the translation. Yeah. You're welcome. Well, you guys, if you want to go to China, like very soon, you really don't have to spend time learning Chinese. Very soon, you can just carry a translator, and then you will not have any language problems in China.
Hello, thank you for your presentation. I just have a simple question for the app that make a poem from particular keywords. Can you just give us an example for particular keywords and the poem in Chinese language?
Oh, that example.
Can you just read it for us so I can hear it, so I can figure out how the app work?
Oh, you want me to read the Chinese poem? I am not sure whether I'm a good poem reader because it requires emotions. But I can, just for fun, I will read like a robot, not like a human being. Okay, so this is a simple one, right?
Okay.
The title of the poem is Happy Chinese New Year. Yes. And those 4 words, 1, 2, 3, 4, because there are 4 lines, right? Each line is one line of the poems. This is new. This is spring. This is happy. So, Happy New Spring. There's a Happy New Year. Those are the 4 words we put in the input boxes. And then each word becomes the first word of a line of the poem. Yeah, that's clear, right? So the poem reads like, you want me to read it in Chinese? Okay, I will read the translation. Okay, I will do the robot translation. So the first sentence says, it's a new year, new spring, and a new century. The second line says, the spring is greeting you with a green branch. Does that sound like a poem? No?
Yeah.
Yeah. And then the third one says, it snows. Snow under sunshine sparkles the whole room, or lights up the whole room. And then the last one says, the happy clouds are coming to look at the continent. Okay, that doesn't sound like a poem very much.
Thank you very much. I just wonder if the Chinese poem, like if it's like Arabic poem. So, but I think the Arabic poems is much harder than Chinese poem because we have some tune. We have to end by particular tune in the end of the.
Because I don't know about Arabic poems, but Chinese poems are very difficult. But I can make a proposal because some of my colleagues will stay here for a while, and then maybe just using your weekends at a later time, you can try to build a robot that can write Arabic poem using similar technologies. Because I was talking about the different layers of AI applications. At the fundamental level, they are similar.
Okay, that's amazing. I didn't know that this app make Arabic poems.
We built this application. We only used 2 weeks to build this application. So if there is motivation, if we have a research topic in the school to build a robot that can write Arabic poems, we can do this like probably in 2 weeks.
Thank you very much.
Okay, we go back to the definition of intelligence, just like the definition of emotions again. So, but the poems are much better than a lot of Chinese young people can write today. That's why I say very few Chinese people can write old style Chinese poems anymore. So the machine can write it. Well, you can say it's not intelligence, or you can say it's not a real poem. But if in China, if we don't tell people this is written by a robot, people can't tell. No. They can't tell the difference whether this poem is written by a person or this is written by a system.
I will ask you a question. It is really artificial intelligence. If I say to the machine that it's not good, it's not a good poem, in the next, it will be better.
The machine will, yeah. That's a very good question in training artificial intelligence in AI. That's the feedback loop. Yeah, that's actually a very important factor.
Because I can accept it in the first step, okay? This is a poem, I don't like it, I say, no, it's good, it's not good, give me another. If it's better, I can say, maybe it's really artificial intelligence. But if it's worse, no, it's not artificial intelligence, it's random.
Yeah, so far we can't do that. Our robot poet can't do that, but because it doesn't. This project is for free. It's just for fun. It doesn't make any money.
I know that is for fun. That's why I said it's not really artificial intelligence.
It's for fun. But if we build that feedback loop into the system, it will improve. Yeah, it will improve. Yeah. That's why feedback is
a project. It's not really the project. For a project, it's a good idea.
Okay,
Well, just to give maybe a better insight on percent, and what percent, how percent can collaborate with universities. So what are your projects, or what are the projects by percent that can, that are programmed or that you foresee, of course, here in Morocco?
I can ask my colleague to answer that question, but as far as I know, so far, certainly poem writing robot is not on the list. It's a pity. We should put it on the list.
CIC and percent, we are here. Ok. So, donc je vais parler en français. Donc, nous, CIC, avec Person, on est en train de travailler avec Nancias en termes pour répondre au label projet qui est en cours. C'est une université. Donc, il y aura nos collègues, Monsieur Ko, le docteur Ko, qui va rester un mois ici à Nancias pour essayer de monter les dossiers avec les enseignants, les professeurs. Il va d'abord, c'est-à-dire avoir une discussion séparée avec les différents responsables et voir une liste des projets. Et après, on va essayer de dire quel est le projet en priorité et on va essayer de monter le dossier. Donc, nos collègues, Dr Ko, il va rester là pendant un mois. Il va rester autant comme il faut pour monter le dossier. Sinon, CIC, on est basé à Casa. Donc, on est en train de faire le prospect dans beaucoup de domaines pour la banque marocaine, pour l'assurance marocaine. Et aussi, nous travaillons avec les gouvernements pour essayer de voir des projets de digitalisation. Donc, on pense que la collaboration avec vous, avec Nancias, avec la société, avec l'école, ça va porter plein de features. Bien sûr, bien sûr.
Merci pour ces informations en tout cas qui sont bien claires aujourd'hui, que nous n'avions pas. Et puis je suppose que vous reviendriez d'un côté pour les projets avec une programmation plus précise pour des entretiens et d'une manière plus générale pour revoir nos étudiants et voir quels sont bien évidemment les profils, peut-être non seulement identifier des profils, mais peut-être mieux les orienter, hein, de manière à ce qu'ils puissent devenir aussi de futurs prospects donc pour votre entreprise. Et puis l'ouverture, bien sûr, sur la Chine. Je ne sais pas ce qu'il peut y avoir à travers vous, des collaborations université et université, entre universités.
On est en train de parler ça avec le DG. Donc, dans notre vision, c'est-à-dire sur l'appel à projet actuel, nous avons, c'est-à-dire il est réparti sur de nombreux domaines, mais nous avons déjà, c'est-à-dire identifié des domaines, on a des applications très mûres. Donc, on peut commencer par ce domaine-là. Donc, on va fournir des formations, on va fournir des outils, c'est-à-dire ce sont des applications mûres. On va fournir une infrastructure, mais comme vous le savez, le big data et l'intelligence artificielle, il a beaucoup besoin d'adaptation locale. Donc, on va tout d'abord apprendre ce modèle aux étudiants, comment utiliser et comment améliorer. Et donc, ce sera à travers cette collaboration, on va concevoir une application locale qui peut servir les clients locaux.
C'est bien que vous teniez compte du contexte local, parce que c'est très important. Même les émotions, ça dépend du contexte local et de la culture. Quelque chose qui peut faire rire un Marocain, peut-être ne fera pas rire un Chinois, et le contraire. Donc il y a ce côté-là important.
Alors il y a un côté qui m'intéresse aussi et qui intéresse certainement les étudiants, c'est l'entrepreneuriat. C'est de développer des startups orientées intelligence artificielle et les accompagner. Donc est-ce que c'est aussi dans votre ligne de conduite en fait?
C'est pour ça on utilise, c'est-à-dire comme il y a l'appel au projet qui est imminent, donc on va tout d'abord utiliser cette opportunité pour commencer la collaboration et au fur et à mesure, on peut avoir une équipe conjointe qui peut répondre à certaines problématiques de société marocaine. Et à ce niveau-là, on peut commencer à penser les start-up chez le Valais, vous savez.
NCS Valais, absolument.
Vous avez des choses mûres en
Pardon? J'ai pas.
Vous avez des produits qui sont déjà mûrs dans le domaine de l'éducation, de l'enseignement et de la santé.
Alors, c'est-à-dire, dans l'éducation, comme moi je suis le représentant, donc on a déjà, c'est-à-dire, il y a le DG qui a exprimé le même besoin, donc on est en train de recueillir les informations de nos différentes filières, donc au fur et à mesure, il y a personne, il y a aussi, c'est-à-dire, une centaine d'entreprises, de filières, qu'on peut faire introduire au fur et à mesure à l'école. Donc d'après ce que moi je savais, c'est-à-dire on a des projets pour diagnostic de cancer, c'est-à-dire c'est des robots de lecture de graphes CT, donc qui permet d'identifier si il s'agit de cancer et de quelle phrase. Mais ça va aussi, ça permet une diagnostic précis. Mais parce qu'aujourd'hui, le problème, c'est que dans une zone rurale, les docteurs expérimentés, ils ne sont pas, c'est-à-dire accessibles, disponibles à toutes les zones. Il y a une inégalité. Mais à travers ce robot, les zones rurales, ils peuvent bénéficier de ces technologies.
Oui, tout à fait.
Bon, alors peut-être que M. Ko voudrait dire un petit mot avant de clore la session.
Donc, ok. Je vous remercie beaucoup d'être présent. Donc, il y a notre docteur qui est là. Il travaille 24 heures sur 24 heures. C'est humain, c'est humain. Donc, si vous avez des questions, si vous avez des idées, n'hésitez pas à lui contacter. Il est là. Ouais.
Parfait, on pourrait peut-être recevoir l'information d'un email, par exemple, pour faire part justement des questions que pourraient avoir aussi bien les enseignants que les étudiants.
Il va vous
inscrire, oui, parfait. Parfait. Non, mais ça aussi.
有问题给你发邮件。24小时工作，不休息。差不多。你说我来打，你再发邮件给我。然后 and 中间有个点，一个国人都是小写，全小写。person.com 是吧？
So my colleague will stay here for another 1 or 2 or 3 months, really depending on how many things he will have here. If you have a lot of a project with him, maybe he will stay longer. But for today, is there any other question that we haven't covered?
or we can just call it a day.
Heureusement, l'équipe de Percent qui est là, qui va surtout rester pour une meilleure collaboration, hein, entreprise, université et plus large encore. Donc, si vous voulez bien applaudir avec moi, donc nos hôtes, merci. Merci infiniment et tout le plaisir sera pour nous de collaborer, comme on dit chez nous, Inch'Allah. Merci, merci.
Thank you very much.